Hello everyone, welcome back to our channel. So now in this video we are going to solve daily problem of LeetCode, that is concatenation of consecutive binary numbers. So let us see first what is the question says. So there will be one integer n and what they have asked, they need to ask the decimal value of binary string formed by concatenating the binary representation of 1 to n in order, right? So see, if you see the example, I given one input n and my output is 1. So how? See, our task is to concatenate all the binary representation from 1 to the given number. So, if my n is 1, right, and my output is 1. So, how? The 1 to n means now my n is 1 only. So, it will give the solution up to 1. So, 1 in binary correspond to the decimal value, that is 1 only. So, if you see the second example, that is n equal to 3. So, in binary representation from 1 to n, that means from 1 to 3. So, for 1, the binary representation is 1. Then for 2, the binary representation is 10, right? That means 1, 0. For 3, the binary representation is 1, 1, right? So, if we concatenate these 3 values, that means this what we will get after concatenation, then we have concatenation, then we have 1 and 1 0 and then 1 1. So this 1 is for 1, this 1 0 is for 2 and this 1 1 is for 3. So the decimal value of this binary number is 27. Understood? So this is how we are going to solve this problem. If you see the third example, the n is 12, right? So we need to concatenate the binary value from 1 to n, right? Then 1 to 12. So 1 to 12 means binary value of 1, binary value of 2, binary value of 3, 4, 5, 6, 7, 8, 9, 10, 11 up to 12, right? So see here, this 1 is for 1 and this 1 0 is 2 and then this 1 1 is for 3 and this 100 is for 4 and 101 is for 5, then 110 is for 6 and 111 is for 7 and 1000 is for 8, 1001 is for 9 and 1010 is for 10 and then this is for 11 and finally this is for 12. So this is the concatenation of binary values from 1 to 12. If we convert them into decimal value, that would be like 118505380540. So this is the decimal value of that binary number, right? So after the module of 10 power 9 plus 7, result will be 50537479714, right? So this is the explanation of this question. So we will try to understand this question, right? So I hope you understood this question, how the answer is coming and how the logic is working here. So now we will write line by line code for this problem and we will explain it, okay? So first, we are going to take one long integer. Why means we are getting long number, right? See, in this third example, when the n is becoming large, we are getting the large numbers. So in string we cannot store that. The string becomes very large. So we cannot actually store it as a string. So instead we build the number mathematically using bit shifting. Okay. So why we are not using strings? Because the binary string becomes very large. So we cannot actually store it in as a string. So instead we build the number mathematically using bit shifting, right? So first I am taking one long. to store the long number. Mod equal to one big prime number, right? So why we are using? Because we use this modulus because the number becomes extremely large, right? So this is a common trick in competitive program to prevent overflow. To prevent from the overflow, we are using this mod because it is a very large prime number which keeps the number in safer integer range. Okay, so this number will keep the integer in a safe range, right? Then long answer equal to 0. So it will stores the correct concatenation decimal value. So here we are returning the final decimal value, right? So this answer will hold that final decimal value, right? So initially nothing is concatenating, so we are giving 0. So then int bit equal to 0. So why I am giving a int bits equal to 0? This stores how many binary bits are required to represent the current number. See, if I given here 3, right? So if it is 3, there will be 2 bits, right? So see, here we have 1, 2, 2 bits, right? So based on we are checking how many binary bits are required to represent the current number, right? So if we see example like example 1, okay, that means it in bits it will store 1 bit. If it is 2, the input is 2, then we will store 2 bits, right? If the input is 3, we will store 2 bits in it. If the input is 4, we will store 3 bits in it, right? So we need this to shift correctly, okay? So next, what we are going to write means, we want binary representation from 1 to n, right? So for that I am using loops to iterate to 1 till the end n. So I am starting from I equal to 1, right? Then I should be less than or equal to n. We are including n also, right? Then I plus plus. So this loop will run from 1 to till n. That means equal to n, right? So we concatenate binary numbers from 1 to n, right? So then we will write one condition. What condition? If my I and I minus 1 equal to 0. Then what I am going to do here? I am going to increase my width. So why we are writing this condition? So this check if my I is a power of 2. That means my I is a power of 2 means like 1, 2, 4, 8, that all power of 2, right? So if it is a power of 2, then what we are doing? We are going to increase my bits, right? So for power of 2, what are the values we will get? So 1 we will get 0, 0, 1, right? So for 2, what we will get? Here we will add another 0. So for 2, what we will get? 0, 0, 1, 0. For 4, what we will get? 0, 1, 0, 0. So for 8,000, right? So for such number like 1, 2, 4, 8, this condition will be checked. So what condition? I into I minus 1, that should be equal to 0. So if we see example like Take the number, so I is 4. And we are using AND operator here, right? Then I minus 1 means that is 4 minus 3, right? So 4 minus 3 means, 4 minus 1. Then what we will get here? We will get 4 and 3, right? So 4 minus 1, it will be 3. So if we do AND operator in between them, what we will get? So what is the binary representation of 4? That is 1, 0, 0. Then in between we are doing AND here, right? Then what is the binary representation of 3? That is 0, 1, 1, right? So if we do AND operator between them means what we will get the answer? So 0 and 1, what we will get? 0, because in AND operator it will true only both the inputs are 1, right? Then 0 and 1, again it is 0. Again 0 and 1, again it is 0, right? So this is the final output when we do AND operator between 4 and 3 and we got 0, right? So whenever we are getting this 0, that means the I is power of 2, right? See, our I is what now? I is 4, right? So I is power of 2. So when we are getting this 0 here, that means the I is power of 2. So then we will increment the bits, right? So why? Because so for 1 we will get 1 bits, right? For 1 we will get 1 bits. For 2 we will get 2 bits, and for 3, so here we are taking for power of 2, right? So then for 4 we will get 3 bits, right? Then for 8 we will get 4 bits, right? So if it is power of 2, then we are increasing the bits, okay? We are increasing the bits count, right? So then what I am going to write? Therefore I am going to write answer equal to answer left shift bits. Our bits we are incrementing here, right? That bits. Then modulus mod plus I and modulus mod. Okay? So don't get tension by seeing this much line. So we will explain, okay? So don't worry. So in this problem, this is the most important line, okay? So this will calculate our answer, our final answer, that is our decimal value, right? So what this line holds, and first we will see about this answer left shift bits. So this symbol represent left bits, right? So left shift means we will multiply by 2, okay? 2 into bits, that's it. So left shift means we will multiply with, right? So see here, answer left shift bits is nothing but we are multiplying by 2 power bits, right? So left shift means we will multiple whatever we have this side, we will multiple means we will add it by power, 2 power bits, right? So why we are doing that? Because we are making space for new binary digits, right? We are making space for new binary digit. So example, if our current answer is, let's take 110, right? So if just take our current answer is 110 and the next number as 2 bits and the next number has 2 bits. Okay. Then what we will do here? 110 left shift 2, right? So left shift 2 means what we will get? We will get the answer as 11 11 0 0 0. And so we left shift to attach new binary number, right? So why we are using this? Because we are making spaces for new binary digits. For example, if our answer is 110 and if we have next number, that means in which next we have 2 means. Now what we have? 110 left shift 2, right? So how there you are calculating means left shift means what? 2 power whatever we are giving here, that, right? So if we see our final answer, now in our answer there will be stored 1130, right? So then what will happen? Then now we will add the I, right? So this I, here we are adding the I. So here this modulus mod, it will not give anything, okay, just for to keep the value small and prevent overflow, we are using the percentage mod. That means we are dividing it by modulus. It will not do anything, it will just prevent overflow, right? So now when the I is added to the number, its binary is appended, right? So now we add I to our binary number. So this is our final binary number, right? That means 11000. So we will add I to it. So if example 1130 and my I is 11, right? So I is 11. So what I will get? 11000 11, right? So when we add up, we will have like this, right? So we effectively concatenate. So again we have this percentage mod. So why we are modulating here? To prevent the overflow, right? So to prevent the overflow. So finally what we are returning? We are going to return those answers, right? Understood? So what we are doing? Why we are taking this? So we are taking first, what our question says? We need to return the decimal value of the binary string formed by converting the binary representation, right? So 1 to F. So what are the example we have? So if our input is 3, we need to concatenate the binary value from 1 to 3. 1, 2 and then 3, right? So the one binary value is what? 1. For 2 it is 1 0, right? Then for 3 what is it? 11, right? So after concatenating, what we will have? 1 1 0 11, right? 1 1 0 11. 1 for 1, 1 0 for 2 and double 1 for 3, right? So if we concatenate that, we will get 11 0 11. So which corresponds to the decimal value of 27, right? Then now here for that what we are doing? We are not using strings because the binary strings become very large, right? So we cannot store it as a string. So instead what we are building? We are building the number mathematically using bit shifting, right? So we are using bit shifting and we are building the number mathematically by bit shifting. So first, why we are using this long mod? We use this modulus because the number become extremely large. So This is a common trick in competitive program to prevent the overflow. So we use this modulus to prevent the overflow, right? So why we are taking this much long number like 1, 0, 0, 0, 0, 0? Why we are using that? Because it is a large prime number used to keep numbers in a safe integer range, right? To keep the integer in a safe integer range, right? Next, what we are doing here? Next, we are giving the answer equal to 0, right? So, this variable stores the correct concatenation decimal value. Right? So, initially, nothing is concatenated, so I set as 0, right? So, I set as 0. So, again I am giving here int bits equal to 0. Why I am giving this? This stores how many binary bits are required to represent the current number. So, for example, what we are seeing here? So, for 1, it is 1 bit, and for 2, it's for 2 bits, and 3, we have 2 bits, and 4, we have 3 bits, right? Then, we are using this for loop to iterate to 1 till n, right? So, we need to concatenate all the integers from 1 to n and we need to convert them, right? So, we concatenate binary numbers from 1 to n. So, for that we are using this for loop. Then, we are writing one if condition. If condition, this check if my I is a power of 2, okay? So, this if condition will check whether my I is a power of 2 or not. So, for power of 2, what are the decimal values we have? What are the binary values we have? 1, 2, 4, 8, right? So, for that, we have binary representation as this. So, then, what we are doing here? So, whenever the I is power of 2, the number of binary bits increases, right? So, the number of binary bits increases. Why? Because for 1, it will add 1 bit. For 2, it will add 2 bit. For 4, it will add 3 bits. And for 8, it will add 4 bits. So, in the power of 2 only, it is changing, right? So, then, what we are giving? Then, this is the important line. It will convert them into the decimal value, right? So, we are using here first left shift. Why we are using? Because we are making spaces for new binary digit, right? So, if our current number is 110, what we are doing here? And the next number has 2 bits, we will left shift with them, right? Then, we are adding I with it, right? We are adding with I. If my I is 11, what we are doing here? We are just adding, right? And then binary is appended to the answer, right? So, this modulus will keep the values prevent overflow, right? To keep values small and prevent overflow. And then what we are doing? Finally, we are returning the answer, right? So, let's take one example. So, if my n is 3, okay. So, let's see first the n is 3, okay. So, first 1 will come, right. For what is the binary value of 1? That is 1. How many bits it has? 1 bit it has, right. 1 bit it has. So, the answer will be, initially in my answer what I am having? 0, right. So, 0 left shift. How many bits I have now? 1 bits. So, left shift 1 equal to 0, right. So, equal to 0 and the final answer will be 1 here. In my answer, it will store 1. So, then the loop will iterate, then I will become 2, right? So what is the binary value of 2? 10, right? So how many bits it has? 2 bits, right? So it has 2 bits. Now in our answer what we have? 1, right? So 1 left shift 2, we will get 100, right? Then now our final value is what? 10 plus 100, right? So 10 plus 100 we will get 110, right? So then again the I will be incremented to 3. What is the binary representation of 3? That is 11, right? Binary bit is 2, right? Then what is having our answer? 110, right? So 110 left shift, how many bit it has? 2, right? Then it will be equal to 11000. So what we have in our binary of 3? That is 11, right? So 11,000 plus 11 equal to what? 11011. So finally we have 11011. This represents 27, right? So if we calculate binary to decimal, we will get 27 for this binary representation, right? So we will run this. So all the test cases have passed. Now we will submit this. So the network is slow. Wait. So I think the solution has submitted. Yeah, it has submitted. So thank you for watching. Please subscribe for more videos and support. Thank you.